Okay, good afternoon, class. Okay, this is week 11 topic. Okay, numerical integration. Okay, now the lesson outcomes is upon completion of this lesson, you should be able to solve the definite integral. Okay, so here we will only look at definite integral. Definite integral means you will be given the limit for the integration. You are integrating from a value to another value. This is definite integral. Okay, so these three different methods, trapezoidal, Simpson's, 1/3, and 3/8. These three methods will be used to solve definite integral only. Okay, without the limit, given, we can't get to solve the integration by using this method. Okay, then the second learning outcome is you are able to calculate the area under a curve. Okay, this is the big picture of numerical integration of this course. So we will estimate the numerical value of a definite integral. Okay, so what you obtain is just a numeric value. Okay, because of the definite integral. Okay, definite integral, we will just get value. Okay, so these are the three different methods. We will start with this trapezoidal rule. Okay, so this works by approximating area under the graph by approximate it to a trapezoid. Okay, this one. Okay, when you are given a definite integral, let's say x e to x. Okay, this is a definite integral. And for the trapezoidal rule, the first one, the first method, this one trapezoidal rule. Okay, let's say we have a curve. Okay, we have a curve, and let's say this is 1, this is 2, and this is the fx. Okay, fx function. So integration of this function from 1 to 2 represent the area under the curve. Okay, so what is the value here? That value represents the area under the curve. So we will approximate this area under the curve for trapezoidal rule. For trapezoidal rule, we will estimate this as a trapezoid. Okay, trapezoid. That means trapezoid. We will estimate this area by using this. Okay, we estimate this area, the area of the trapezoid, as the area of this curve. Okay. Now back to the slide. Okay. This is the area under the curve. Okay, we are integrating. This is called definite integral. Okay, definite integral because you are given the values of a and b. Okay, so the output of this is the area under the curve. Okay, when you are integrating from a to b, this one a to b. For this curve, this is the curve. Okay, we get the area under the curve. Okay, so when we need to use this numerical integration, okay, we have two situations. Okay, the first situation is when the function, okay, when the function is impossible for the analytical integration. Okay, analytical integration means you have to integrate the function by using either by substitution, by integration by parts, by substitution by trigo function. All these are called analytical integration. Okay, what you are going to learn now is numerical integration. Okay, so this one, actually for this function, we can't integrate this function. You are unable to integrate this function by using any of the technique of integration that you have learned. Okay, none of them. Okay, so for this kind of question, we need the numerical integration. Okay. Or when your function is a very complicated function and you need to do the integration, okay, the definite integral, okay, you need to find the definite integration for a very complicated function, then we can also use numerical integration. Okay, then the situation number 2, when you are not given the function, but you are given a set of points, okay, you are able to solve this by use from the set of points. Okay, given the set of points, this is similar to the numerical differentiation. You are not given the function, but we are still able to estimate the f prime, f double prime. And now you are not given the function fx, but you are given the set of points, and we are still able to find the antiderivative, the estimation of antiderivative for the definite integral. We are still able to estimate it by using numerical integration. Okay. Now this is the trapezoidal rule. Okay. So given a function, this is fx. Okay, this is the fx. When we want to estimate for this area, suppose the area, it includes this one, right? It includes this, and also this area of trapezoid. Okay, this is trapezoid. Okay, the area under the curve, including this part as well. Okay, but we are estimating the area under the curve by using this trapezoid. Okay. So the area is, we are integrating from xi up to xi plus 1. Okay, xi up to xi plus 1 for this fx function. Okay, the one in green for this fx function. So this is approximately equals to the area of this trapezoid. Okay, the area of this trapezoid. So if you still remember the area of the trapezium. Okay, when we want to find for, this is parallel, this is AB, this is H, right? The area of this trapezium, okay, is 1/2 times H times A plus B, right? If you still remember, okay, the area of this trapezium, the formula is this one, 1/2 times H times the sum of these two parallel lines. Okay. So if you look at the slide, this one, you have this. This is, here I use x and xi plus 1. Okay, we want to estimate. Okay, we want to estimate this trapezoid. So these two are the parallel side. Okay, the parallel side, the AB. So what is the length of this? What is the length of this? This one, right? This is the length. The length of this is fxi plus 1. Okay, so the area, okay, area of this, okay, area of this, if we use the trapezium, it will be 1/2 times the h. The h is the distance between the two parallel lines. Okay, that's mean this one. the distance between the two parallel lines. This one is the h, the step size. Okay, the step size, the h here is the step size. And the sum of the two parallel lines, the length of the two parallel lines. That means this is fxi. fxi plus fxi plus 1. Okay, so we get this. Okay, so when we look at this one, h over 2 times the sum of fi and fi plus 1. Actually, it's referring to this one. Okay, the one at the blackboard, half times h step size. This is fi, this is fi plus 1. So that's why we get this formula. Okay, and this formula is for one trapezoid. For one trapezoid, this one. This is only one trapezoid. Okay, since when we want to estimate the area under the curve, we are estimating using the trapezoid. That means there are some errors here. These are the errors. So when we want to reduce the error, we can break this into a number of subintervals. When we have a number of subintervals, you see this one, this one, this one, this one. The error will be reduced when you have a number of subintervals. Okay, the error will be reduced. So this one, let's say we have x naught up to xn. We are integrating from x naught up to xn for this fx. Okay, so we will break this one into a number of subintervals. So this is x naught, x1, x2, x3, up to the last one, xn. Okay, that means we will estimate this, okay, this part using one trapezium, this part using another trapezium. Okay, this is a third trapezium. So we will break this one, x naught to x1, okay, and then x1 to x2, the integration, because we break this integration into a number of parts. So this will be also break into a number of parts. Okay, x0, x1, x1, x2, that means the second one, x1, x2, x3, and so on. So when you have this, that means you have more than one trapezium. Okay, so the first trapezium, this is the formula. Okay, x0, x0, x1, that means f0, f1. Okay, the length. Okay, this length, this one, fi plus 1. This is fi. Okay, so for this one, the formula will be f0 and f1. This one, this is f1, f2. So you have, we are using the formula, okay, for each of the subintervals. Okay, so this is the one. So when we combine, okay, when we combine all this, you will get the trapezoidal composite rule. Okay, so this formula will be given in the appendix, okay, for the trapezoidal and the Simpson's rule. Okay, so this one, you see, f0, all this have to multiply h over 2 and then you sum them up. So the f1 repeat 2 times, f2 also repeat 2 times. Up to the second last f, you have 2 times, right? Okay, f0, f1, f1, f2, f2, f3. So that's why this f1 up to the second last f, you need to multiply 2. And for the first one, f0, and the last one, fn, you just sum up the head and tail. This one I call this a head. The last one is tail. Okay, because when you expand this, you will see that f1 repeat twice, f2 repeat twice. The one in between head and tail, they are repeating twice. That's why you have a 2 times this. Okay, according to the formula. Okay, this one you can expand. You can try to expand, and you will get this. This is the formula of the trapezoidal composite rule. Okay. So far, any questions? Okay, now we look at the first example. Okay, given this set of data, we want to use trapezoidal rule to estimate the area of this from 1.2 up to 1.7. Okay, 1.2 up to 1.7. And the number of intervals will be 5. Okay, 5, that means 1, 2, 3, 4, 5. You have 5 intervals. Okay, you have 5 intervals. Okay. We look at question number 1, solution of question number 1 first. Okay, so this is the question. We have 5 sub-intervals. And according to the formula, okay, we need h over 2. Okay, we need to know what is the h. So based on the data here, we know that h is 0.1. Okay, h is 0.1. H 0.1, okay, divided by 2. And the head and tail. Okay, head and tail, this one. Okay, here you need a table. Okay, you need a table. You display all the x. Okay, you display all the x, and their corresponding f in this way. That means this column, you just put the head and tail of the f value. Okay, the f value, the head and tail. And for the rest of the f value in between these two, okay, in between, that means this one. The f value, you put it under another column. Okay, that means this column, it just accommodates for the head and tail. Okay, h and t. And the last column accommodate for the fx for the rest of this. Okay, then you sum this up. Okay, sum this up, you get this. Because according to the formula, we need the sum of the head and tail. So we put the head and tail under one column, and the rest of the f, we put it under another column. When you sum this up, you need to times 2. Okay, times 2. So that's why this 18.5 times 2 plus the sum of the head and tail. Okay, multiply to the h over 2. Then you will get the estimation of this integral. Okay, this integral. Okay, actually, this numerical integration is very simple. Okay, very simple. Okay, any questions for this number 1? For trapezoidal rule, okay, for trapezoidal rule, we need to break the fx into 2 columns. 2 columns. The first, just head and tail. Head and tail. And the second f value, the second f column will be the rest of the f. Okay, and this I stand for iteration. Okay, iteration always start from 0. Okay, 0, 1, 2, 3, okay, up to 5. Okay. Okay, now we look at the second question. Use trapezoidal rule to estimate this one. Okay, this one. This one, f squared. This is different from the first. This is f. This is f squared. Okay, we are estimating the similar thing. It's just that f is square now. And we need to multiply the pi. Okay, after you get the estimation from numerical integration, you need to multiply pi to get the final answer. Okay, the step size is 0.1. Okay, we are still using the same set of data. Okay, so your data start from this 1.2 up to 1.7, 1.2 up to 1.7 with a step size of 0.1. Okay, these are the corresponding f values. But what we want to estimate now is f prime. So you have to square all of this f and allocate them at the proper column. Okay, so this one, after square, head. After square, tail. Okay, you sum these two up, you get this. And for the rest of this, you square each of them and you put them under this column. Okay, sum them up, you get this. Then you put these two into the formula. Okay, h is 0.1. The sum of head and tail is this one. And then plus 2 times the sum of the rest of f. Okay, and do not forget about the pi here. Okay, multiply the pi, then you will get the final answer. Okay. Okay, example number 2. Use the trapezoidal rule to estimate this definite integral with h is 0.1. Okay, so this one from 0 up to 0.8 with the step size of 0.1, you need to construct for a table. Okay, you need to construct for a table starting from 0 up to 0.8. This one, 0 up to 0.8 with a step size of 0.1. Okay, after that, we need to get their corresponding f value from here. You just substitute the x value into here, you will get the corresponding f value, and you allocate the f value accordingly. The first one, head, you put under this column, tail under this column, and the rest of the f, you put it under this column. Okay, so you sum these two up, you get this. You sum this up, you get this, and put these two into the formula. Okay, h over 2, the sum of the head and tail plus 2 times the sum of the rest of the f. Then you get a final answer. Okay, any questions? Okay, now we try this exercise. Okay, your x starts from 1 up to 2. Okay, so x starts from 1 up to 2, and the step size is 0.2. Okay, so 1 you plus h, plus h, plus h, plus h. Then you stop here. Okay, the iteration always start from 0. 0, 1, 2, 3, 4, 5. Okay, this one is quite important for the Simpson's rule. Okay, for trapezoidal, actually you can ignore this one because we know that the head and tail, the f will be here. Okay, but for the Simpsons, we need this iteration column. Okay, so now you can key in this function into your calculator, and you just calculate to get their corresponding f value, and allocate your f at the correct location, head and tail, and the rest of the f you put it here. Okay, then sum them up. Okay, the formula it will be 1h over 2. Okay, then the head and tail plus 2 times the sum of the rest of f. Okay, try. X E certain point X. Use 4 decimal places. Okay, if it doesn't state in the question, use 4 decimal places.
Okay. Udah. Yung gunang pag-listen ng dua. Dapat yan FX1 kita kan check in din apa. Yang itu semua semua kayak itu. Atau lawan saya lebih faham. Sudah dia and di dalam ini ya. Ini dulu dulu ha.
Okay, once you get the sound, you just put them into the formula.
Muta.
So for trapezoidal, we need the sum of head and tail, and then the rest of the sum will be multiplied 2. Okay. So your h is 0.2. Okay, your h is 0.2.
8.0.
So you should get 5.2372.
Yang mana? SB2 ni. Tadi pemilih dia. Saya tidak pasti pada kita tanya dia dulu.
Okay, got it?
Oh, okay.
Okay, so sometimes the question they will mention about the age. Okay, then you know what is the age, right? Okay, what is your X value? Sometimes age is not given. You are given something like question number 2. Question number 2, it gives you the n, the number of subintervals. But if you know the starting point and the end point and number of subintervals, you can also get the age, right? Have you done question 1?
Done.
Done. Then we look at number 2. Okay, then see number 2, you are given this. You are given this. Okay. Okay, how to get age? Age is actually this is A, this is B, yeah. So B minus A divided by M, right? We want to know the distance between this, and then divided by N, we will know what is the age. So your age is 3 minus 1 over 4, which is 1 over 2, right? Okay. Then okay, the starting is 1. Starting 1 ends at 3. Okay, 1 ends at 3. So 1 plus 8. Okay, plus 8 plus okay, plus 0.5, then plus 8 plus 8 plus 8. Okay, we will stop at this. Okay, then use your calculator to get the F value.
Only. Dạ. Thì đêm tôi
Nambah-nambah ya. Gidi dulu.
Ban.
Ngayu dulu. Ya, ya, ya. Di bawah kopi juga. Siapa? Ini tak banyak gol.
Jadi Simpson. Simpson. Kalau bulan semalam bulan. Tapi ya mesti. Ini saya tuan kita. Thank you. Apa persen?
Okay, number 3,
How to
0 to pi over 2. Sin x over x. H is pi over 8.
ini pakai ini.
Calculator.
This one, no degree sign, right? This is the angle. Angle, when you angle, you didn't see the degree sign, that's mean radian. Okay, 0 up to pi over 2. 0 up to pi over 2. With a step size of pi over 8. Okay, this one you can use the pi over 8. You keep plus pi over 8 until you get pi over 2. Okay, pi over 8 plus pi over 8. Pi over 4. Okay, and then plus again pi over 8. 3 pi over 8. And then this one, pi over 2. Oh, we have only this view.
Okay.
Okay, When x is 0, what do you get?
0.
Then 0. Error. Have you tried? When you substitute 0, of course you get error. Over 0, of course you get error, right?
Yeah.
Okay, so this one, whenever you
Vậy thì nhà công nghe bạn.
x and c f c is d equals to 0/0 or infinity over infinity. Okay, whenever you have a case like this, when you substitute this one should be x. Huh? When you substitute the x, okay, with a value into here and here, and you get 0/0 or infinity over infinity, then you need this L hospital rule. Not hospital, hospital. I think this L hospital. Yeah, L hospital rule. You have this apostrophe S. L hospital rule. That means we need to send this to the hospital, right? To settle this issue, 0/0 or infinity over infinity. So how to solve this? So under this rule, okay, under this rule, okay, this one it will be okay. We will get this. We will have this. Okay, this rule, okay, under this rule, okay, we will differentiate f and g separately with respect to x. Okay, separately with respect to x, differentiate separately. Differentiate f, you get f prime. Differentiate g, you get g prime. Then only we substitute the c into the x to check whether you still get 0/0 or infinity over infinity. If yes, apply the L Hospital's rule once again. That means you differentiate. If no, then we will get the result. Okay, for this case, this is limit x tends to 0 for sine x over x, right? So for this case, when you substitute 0 into x, you get sine 0 is 0, 0/0. You have this case. Then we apply this. When we apply this, you will get sine x, differentiate sine x, we get a cos x. Differentiate x, we get 1. Okay, then we substitute 0 into x again. What do you get? Cos 0 is 1. 1/1, 1. That's why you get 1.
Là jadi differentiate yang gimana pakai area jadi kan cek lah kan
Okay, so we will use this L Hospital's rule whenever after the substitution into the fraction function, you get 0/0 or infinity over infinity. Then we use this. But if what you obtain is a constant over 0, you can't use this. It must be 0/0 or infinity over infinity. Then only you can apply this. Okay. Then for the rest of the values, we have no such an issue to get error, right? So for this 4 f values, you just compute as usual.
Ini. Si cantik tu dah. Boleh siap bunyi ni. Oi, sikit pening ke kereta? Langsung mana? Itu mana cantik? Atau pening sama. Ay, kelas kau. Itu pakainya kos dia yang pakai lagi.
Video pakai sidak kan?
Itu use
It's the next over
what or
That's what
I don't get it. It's like
okay. I rub this off.
video lah,
So 5/8 divided by 2, and this one plus 2 times 2.659 divided by 2.
tak apa. Kita kena ada guna. Guna X. Kena guna X kan.
See? You it's right here.
Divided by 5/8.
Dicintai itu bagi-bagi. Iya, pakai pulsa.
The values of this, you have to use this one, sin x over x. The cos x just now is just specific for this case when x equals to 0. Because when x equals to 0, it gives error. That's why we use L'Hopital's rule. But when your x is all this value, there's no issue. Okay, done. Any questions? Any questions? Now we look at Simpson's. Okay, Simpson one-third rule. Okay, Simpson's one-third rule. So this rule is approximating the integral of a function using quadratic polynomials. Okay, now look at the screen. Okay, look at the screen. What is the difference between this Simpson's one-third and also the trapezoidal rule? Just now the trapezoidal rule, we estimate the area under the curve by estimating the trapezoid area, right? But for Simpson's one-third rule, we are approximating the area under the curve by approximating a quadratic polynomial. Okay, a quadratic polynomial. Meaning that for this area, we have what 3 points. 1, 2, 3. Because to estimate, to get a quadratic curve, we need 3 points, right? That's why, okay, we need to have 2 subintervals. Okay, we need to have 2 subintervals, minimum 2 subintervals, and 2 subintervals, they will work as they will work together. Okay. So when we break this, okay, when we break the subinterval, okay, you have to make sure your total number of subintervals must be even number. Because we need 3 points to estimate for this part. Okay. Now if I break the subinterval into smaller subintervals, okay, so this 1, 2, 3, this quadratic curve will be used to estimate the area under the curve. And then this 1, 2, 3, we will interpolate these 3 points to get a quadratic function. And then we estimate the area under the curve of that quadratic function. So that's why your n, okay, your total number of subintervals, it must be in multiple of 2. You cannot have odd number because 2 makes a pair. 2 makes a pair. If you want to use Simpson's one-third rule. You get what I mean? So this is the condition. This is the condition. If you want to use Simpson's one-third rule, your n must be multiple of 2. Otherwise, you can't use this. But for trapezoidal rule, there is no such condition. The number of n can be any values, can be any integers. Okay, now we look at the formula. This one from the first point until the last point. So this one, x0, x1, x2. We have x0 up to x2. This is for 1, this one. one formula. One formula represents the area for two subintervals. Okay, this one is for two subintervals. And how to get this? This is actually from the Lagrange interpolation. Because we interpolate these 3 points to get a quadratic function. And when we get a quadratic function, we estimate the area under the curve of that quadratic function. Okay, so what we obtain, we will assume that is the area under the curve of this fx. Okay, so this is the formula for two subintervals. So when you have a lot of subintervals, we have something like this. So that means each of this integral, we have this. And the second one, we have this. So when you expand and you combine again, you will get a Simpson's composite rule. Okay, this one. Because next one, you still have another one called Simpson's 3/8. Okay, 3/8. So whenever you see the Simpsons, it didn't mention 1/3 or 3/8. That means it represents 1/3. If you want you to stop using Simpson's 3/8, it will mention the Simpson 3/8. Okay, but if sometimes it doesn't mention 1/3 or 3/8, that means it's referring to 1/3. Okay, so this is the formula for the Simpson's composite rule, the Simpson's 1/3 rule. So now if you look at this formula, you have the sum of the head and tail. And what are the difference between these two? This is odd number, right? These are even number. The number here is referring to the iteration, not about this one. Okay, this one, whether it's odd or even, doesn't matter. We look at this, the iteration, this one. So here we need 3 columns. We need 3 columns. The first column for head and tail, the second column for the odd iteration, and the third column, it will be even iteration. Okay, so those from odd multiply 4 and those from even multiply 2. So this is the formula for the Simpson's composite rule. Okay, now we look at, this is the derivation of formulas. Okay, this one you can go through on your own. I will go straight to the example. Okay, this is the example. Okay, this is the given set of points. We want to use the Simpson's rule. That means the Simpson's 1/3, the 1/3 rule, to estimate this one. Okay, from 2 up to 6. Okay, 2 up to 6. H is 1. Okay, H is 1. So this is your table. Okay, 2 up to 6. So 2 until 6 with a step size of 1. And this is the number of iterations, 0, 1, 2, 3, 4. So we have the head and tail. Okay, head and tail. Then we have odd fx, even fx. So for the odd fx, you look at this. This is odd. So this one, you have to put under odd. This is also odd. Okay, odd. So the f of this, you have to put it under odd. Okay, and this is even. Okay, this is even. So wait, I'm sorry, this is even, this one. The iteration number is even. So the f for this value, you have to put it under even column. Okay, very simple. The odd and even referring to the I. Okay, even though this is also even, but since the value are already taken by the head and tail, so it doesn't, we won't put the values here anymore. Because the values has been occupied by the head and tail column. They will just appear once. Okay, they will just appear once. So you sum up this, you sum up this, you sum up this. Then you put these 3 into the formula.
Okay.
Head and tails plus 4 times the sum from the odd column plus 2 times the sum from the even column. Okay, this is h/3. Okay, h is 1. Okay, then you will get the estimation. Okay. Now we look at this. This is exercise. the exercise.
Kita mau apa tu?
Okay, H is 0.25. We have I, XI, head and tail. Odd. And even. Okay, then your X starts from 0. Okay, starts from 0. And you keep plus the H until 2.
Tambah. Tambah. Ya, tambah.
Sampai
Kita tahu dari
Okay, 0.25, 0.5, 0.75, and then 1. 1.25, 1.5, 1.75, then 2. Okay, iteration, number of iterations starts from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8.
Lepas tu kan, dia kan negatif juga. Oh ya.
Nah, kita dulu. Ternyata kalau dulu,
Ini boleh. Ini boleh ni, ini ni. Pijak wah, tekan, tekan.
So you need to know the location that you need to put later, head and tail. Okay, head and tail. And for the odd, this one, for the odd, this one, this one, this one, and this one. And for the even, okay, even, this one, 2, 4, 6 is even. So you have this, this, this. Do not put them under the wrong column.
Sebab orang dengan universe ni kan nombor-nombor kat sini ni banding nak bila kita ada yang tengok apa kalau genap dengan dia kalau dia ritsi sekali yang tidak sampai dengan dengan lagi dekat lagi sama. Waktu kaya jadi orang belakang pun yang ini benar penting bila ya sini apa dia
Okay, got it?
Got it. Wait. Don't use certificate. Jim. Pak dulu. Saya Pak dulu. Boleh palu eh? Mau nampak tadi ya? Mau nampak tak? Oh, tak. Apa ni ya?
Okay. Done. Okay, next one, Simpson's 3/8 rule. Okay, Simpson's 3/8 rule. Okay, this one is similar to the Simpson's 1/3. Okay, but this use cubic polynomials. Cubic polynomials means we need 4 points. 4 points, 1, 2, 3, 4, to estimate a cubic function. So this will be 3 subintervals works as a group. Okay, 3 subintervals works as a group. So this one, the formula from Lagrange interpolation. Okay, we interpolate the 4 points to get the cubic function, and the area under the curve, okay, of this cubic function is given by this. Okay, so this is the area for 3 subintervals, and this must be 3 subintervals work together. Okay, so if we break the subintervals into more, that means the number of subintervals, the total must be in multiple of 3. Must be multiple of 3 because 3 works together. Okay, 3 works as a group. Just like the case just now, the Simpsons 1/3. 2 subintervals work as a group, so the n must be in multiple of 2. And for this case, n must be in multiple of 3. Okay, so if your n is an even number, not even number, if your n is not in multiple of 3, we cannot apply this rule to solve the integration. Okay, so this is the condition for you to use this. Okay, so for each of 3 subintervals, we have the formula of this. Okay, this is the second set of 3 subintervals. This is the next one. Okay, so when we expand and we group it back, we will get this Simpson's 3/8 composite rule. Okay, so all this composite rule formula will be given in the appendix. Okay, what you need to know is which method should be used. Okay, which method should be used. Okay, when you are asked to choose the suitable method. Okay, sometimes it will mention, okay, solve this using trapezoidal rule. Then you have to follow trapezoidal rule. Okay, and sometimes it might ask why this question cannot be solved using trapezoidal 1/3. Then you have to know the number of n. The n must be not a multiple of 2. That's why we can't use the Simpson's 1/3 rule. Okay, so you have to be clear with the condition for each of this method. Okay, now if you look at the formula, this is 3h over 8. This is sum of the head and tail. Okay, now look at this. What are the difference between these two? How to differentiate between these two groups? Three, 6, 9. multiple of 3, right? Then the rest of the F, you just put it under the last column. This second column, first column for head and tail, second column for the multiple of 3. And the rest of the F, you put it under the last column. Okay, we look at this example. You are given this set of data. Use Simpson's 3/8 rule to estimate this one. Okay, starting from 2 up to 3.2. Okay, H is 0.2. We start with H 0.2. Okay, when H is 0.2, starting 2, so next will be 2.2, 2.4, all the way up to 3.2. Okay, then you have to put this iteration number. Okay, so the first column, okay, for the F is head and tail. Okay, for head and tail. And the second FX column, it will be multiple 3. Okay, in multiple of 3. Okay, multiple of 3, that means this one. Okay, multiple of 3, that means 3, 6, 9. This is the only one because 6, this already taken by the tail.
Okay.
Then the rest of the F, you put it under the last column. Then you sum these 3 columns, put them into the formula. Okay, head and tail plus, okay, the one from multiple of 3 times 2. And the rest of the F times 3. Okay, follow the formula. Okay, next one, when we use the H equals to 0.4 with the same, from the same question, we use H is 0.4. So starting 2, 2.4, 2.8, and 3.2. Okay, this one head and tail, but multiple of 3. Multiple of 3, that means 3, 6, 5. The 3 already taken. The only multiple of 3 has been taken by the tail. So there is no
3.
F under this column. And the rest of the FX, you put it under the last column. Okay, put them into the formula, then you get the final answer. Okay, very simple. Okay. Okay, for this question, this example, if the function is given, then you need to compute the absolute error for each of the cases. Okay, if this is given, to get the absolute error, okay, that means we need to integrate this one. This is your fx. Okay, this is your fx. That means you need to integrate this fx from 2 to 3.2 to get the actual value and use the actual value to compare with these two approximated value to get the absolute error. Okay, so if this fx is 1 over 5x minus 9, so we integrate this, we get a long function. Then substitute 3.2 into x minus substitution of 2 into x, you get this actual value. Okay, this is the actual solution. From the h equals to 0.2 just now, this is your estimated value. So we use this and this one to find for the absolute error. So just use this this one minus actual, and we just take the magnitude because this is absolute error. Absolute, we use the modulus, we just take the magnitude. Okay, and this one minus this, take the magnitude, that is absolute error. So if we compare these two, of course, the lower value of h gives a better approximation. Remember this one. No matter it is differentiation, numerical differentiation or numerical integration, the lower value of h, it will always give a better approximation. When the number of subintervals is smaller, your error will be reduced. It will be smaller. Okay, example number 2. This one. With h is 0.5, starting 1 up to 4. Okay, 1 up to 4 with 0.58. Okay, so 0.5. So list out this I. So head and tail. And from all this, multiple of 3 is 3. Okay, 3. And the rest of f, you put it under the last column. Then finally, put them into the formula, get the result. Okay, if the question given n, so you just use b minus a divided by n, you will get 8. So this one, 5 minus negative 1. 5 minus negative 1, you get 6. 6 divided by 9. That means 6 over 9. Okay, 6/9 is 6/9 is 2/3, right? 2/3. So here you can use the actual one. Okay, you can use the actual one. Actual one is easier. So -1, starting from -1, -1 plus 2/3, -1/3. -1/3 plus 2/3, 1/3. You keep on plus the h until the last one you get 5. Okay, so head and tail. And among all this, the 3, 6, 9, the 3, 6, okay, 9 has been taken by tail. So we have only 3, 6 under these two column, this column. And the rest of the F, you put it under the last column. Then put them into the formula for the sum. Okay, sum. These 3 columns, put them into the formula, you get the result. Okay?
Okay.
I'll try this. Okay, 0 to 5. Cos x squared plus 3. Cos x squared plus 3. Okay, your n is 12. Find for your h. Okay, what is your h? 5/12. Okay. So starting from 0, then 5/12. Okay. Take plus the pi/12 until pi. It's quite long.
Ada dua kali.
Jadi malah tanpa dari studi
Kalau semua negeri yang ini
Okay, multiple of 3, 6, 9.
Jadi kalau kita tak boleh sini boleh kita tak boleh sini. Tak orang sini
Bagi dia macam bergegar.
Ini sampai mana? Sampai ke tempat tadi. Ini nomor ini dari rumah. Terus dia datang lagi. Jadi ulang sampai kemudian kosong lagi jadi orang ini macam dikit lah, dikit lah. Banyak nak sampai kita itu apa dia pada ini.
Kalau di mana dia boleh diuji pasang di Dimaksud mga koy tadi sekedar esok nah ini Pak, nanti ada kan ya sesuai itu jadi dia
Okay, if you want to use your calculator to get this, okay, you don't take the time, you just take the 1/12. Just use the 1/12. Just when you factorize the pi, because you are using this one, the first one you get this, and then this one you plus again. This means we factorize the pi. Okay, we factorize the pi. So you don't take the pi, you just use 0 plus 1 over 12. Then insert again the pi. Okay, so 1 over 12 plus 1 over 12, you get 1 over 6. 1 over 6 plus another 1 over 12, you get 1 over 4. Then the way you multiply the pi into the value. Any questions?
Kita tadi tambah-tambah ini apa yang baik. Berada pada bawah tu.
Sebenarnya macam ni tau.
Yang lihat tadi pada bawah ni.
Sampai bunyi isi dekat yang bawah banyak juga kan. Kita sudah sampai baru lah. Jadi sebenarnya yang kedua yang kita cakap
Kita tapi kita tambah
Now we look at number 2. It's 4 minus 2 divided by 9.
0.2222.
2/9. Okay, if you use 0.2222, from 0 you keep plus the 0.2222, keep plus the same value. The last one you won't get actual 4. It will be less than 4.
Alright.
So we use the actual one. Okay, that's what it starts from 2. So 2 plus 2 over 9. Okay, until you get 4.
Ada dapat 2
Ini ya, turungan. Dua tambah ini. Berapa dulu?
tambah 1/2. Jadi saya kalau kita itu tambah dulu dia tambah
Penting lagi 12 lagi. Tak bisa. Dapat 229. Oi.
tak dapat di dalam. Tidak. Ya, tinggi dan pakai lagi. Enggak.
Ini uang apa?
That is white and long. So Okay. Key in this function.
Zero 7.1.
In multiple of 3, in case you forgot, for the one, in over 3, range 4, you range 10 over 3,
Ini boleh bisa. Yang ini masuk kurangnya kau kena dua ni. Ada itu kurangnya cepat, kurangnya tu. Apa namanya berjalan tu? Yang ini dah. Macam minat dia, tanam pun cuma itu perlu mana kan dia. Itulah banyak-banyak tradisi apa. Ada tradisi. Dah langsung dia.
Okay, last question, number 3. Number 3. Do we need to solve this? Number 3. Do we need to solve number 3?
Number 10.
This is Simpson's 3/8. What is the condition? The n must be in multiple of 3. This is not multiple of 3. So this cannot be solved by using Simpson's 3/8 approach. Okay? But this one we can solve using Simpson's 1/3. Okay, but since this is under the 3/8, so we don't have to solve. Since n is not in multiple of 3, hence this question cannot be solved using Simpson's 3/8. This question will be solved using the Simpson's 3/8 approach. Okay. So actually, we have done the syllabus for week 11. Yeah. We are done. Quite simple. Okay, this is quite simple because I think one class may be enough for this week 11. Okay, so next week we still have class with section 2. Okay, section 2. So we will start the week 12. Okay, week 12 syllabus next week with section 2. And for section 1, I will see you next year. Because next Monday is a holiday, public holiday, and next Thursday and Friday, I'm taking leave. Okay, I'm taking leave. No class. No class for next Thursday and Friday. So that's why for section 1, I will see you in the following week, which is next year. Okay. And for section 1, okay, for section 1, I want you to watch the recorded video of section 2 for the week 12 lecture 1. Okay. Okay.
Tadi nak jatuh tu. Nak jatuh tu.
Thank you, doctor.
Thank you, doctor.